In this Excel demonstration, we're going to go through the binomial distribution. The first thing we're going to do is actually build a binomial distribution, and then we're going to talk about how to use binom.dist to calculate the probabilities for when we're using a binomial distribution. So the first thing that I wanted to do is I've got a blank Excel worksheet I've just started to build. And over to the left, I said that our number of trials is 11 and our probability of success is 27%, 0.27. Over here for the distribution, so remember I've got a discrete variable. I'm going to start with 0, 1, 2, and then to get Excel to index, I'm going to highlight these two, and then I'm going to drag them down to that far, and it'll index all the way up to n equals 11. Then under the probabilities is where I'm going to use the binomial distribution command, this function. So I'm coming up here and I'm going to type in binomial to see what Excel returns. And then it says binomial distribution. So I've got these two. This one says for Excel 2007 and earlier. This one's the one I'm going to use is the binom.dist. Okay. And then it wants the number. So this is the number of successes out of how many trials and then the probability. So our number of successes for the very first one is 0. The number of trials is 11. The probability of success is 0.27. And then here's where I have to make a decision on whether I want to cum or sum up all of the probabilities up to and including that value, or just get the point probability for that single point. So I want to just pick what the probability is of 0. So I'm going to say false. And then I'm going to click OK. So let's try that again for practice. So now I want to calculate the probability that I'm going to get one success out of 11. So come up to insert a function, pick the binom distribution, click OK. The number this time is 1 out of 11 trials. The probability is 0.27. And cumulative, we're going to say false. So I could keep doing that and type it down and fill in this whole table. Or what I can do is I can highlight this formula and I can copy it down. And then I can go back and edit it. So I'll go back in here, instead of the probability of a success of 1, I'll change it to 2. And then for 2, so now I've got success of 3, I'm going to change this one. Then this one is a success of 4, so I'll change that one. So I did this all the way up to number 11, and I'll show you my results on sheet number 1. So I took the time, I did all of those probabilities, I copied them all down, and so look at the probabilities at the end. So 1.65 times 10 to the negative 5th, that you're going to get 10 successes out of 11. 5.559 times 10 to the negative 7% chance that you're going to get 11 out of 11. So let's just see what the distribution is going to look like for this probability distribution. So I'm going to come in here and I'm going to say insert. I'm going to pick a column chart. I'm going to pick the very first one. Oops. Insert. Let me try that one more time. Insert. I'm going to pick the column chart. I'm picking the very first one. Oh, I know what happened. I didn't highlight the data. So now I'm going to highlight the data. So let's select data. And this is what my chart looks like. So I need to fix it because right now it's plotting them against one another. So look, I have some red bars down here and some blue bars. So I'm going to click on the select data again. And for this very first series, I'm going to remove it. And then for the horizontal, I'm going to edit that also. And I'm going to highlight what my X value should be from 0 to 11. And I'm going to say OK. Okay. So look at what the distribution looks like. And so you've got this weight up here where your successes are 3, and then how it tapers down all the way down here to your 11. And so you've got that skew. You've got a skew to the right. So this data is skewed right because that probability is 0.27. So the probability is 27%. If you had equally likely events, then the chart, this graph would be symmetric and you'd have that weight in the center of the graph. So that was the first thing that we wanted to talk about today, is just creating this binomial distribution. So now let's look at what if we were wanting to calculate some binomial probabilities. And let's go back, and I'm just going to come back to this page. Actually, I'm going to insert a brand new sheet. So let's say that I have an N of 15. And let's say that I have a probability of 0.73. So let's ask a couple of questions. So let's say, what's the probability that X is less than 4? And then let's ask the probability that X is greater than 9. So we'll ask a couple of different questions. And so when I'm asking the question of the probability that X is less than 4, I want the probability that X is 0 plus the probability that X is 1 plus the probability that X is 2 plus the probability that X is 3. So remember, these are discrete variables, and so if you're less than 4, then you're 0, 1, 2, and 3. So let's do the commands on the binomial to work with this probability. So I want to do a cumulative. So I want to do a cumulative binomial, and I want to do 0 to 3. So I'm going to come over here and I'm going to do my functions. I'm going to pick binomial distribution. Okay. My number of successes, we're going up to 3, right? Even though X is less than 4, we're going to say 3. The number of trials in our case was 15. And our probability is 0.73. This time I do want it to be cumulative. So cumulative means you want to add the probabilities all the way up and including 3. So it'll take the probability of 0, 1, 2, and 3 and add them all together. So I'm going to say true this time. (2.896 times 10 to the negative 5th). So that's the probability that less than 4 out of 15 successes. So let's try greater than 9. So greater than 9 is, the probability of 10 plus the probability of 11 plus the probability of 12. So now what happens? Oh, plus the probability of 13 plus the probability of 14 plus the probability of 15. So I can go through and I can calculate those just like we did when we were doing the binomial distribution, and I can add all the values together. And so I could do that. The other thing that I could do is I could do the complement. And so think about what would happen if I did the complement. And so I want it, so if it's greater than 9, we're going to include 10. So what if I would do 1 minus the probability that x is less than 10. So less than 10 would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if that's what I want to do in this one's case, now what'll happen, so let's come over here and let's calculate what that probability would be. So I'm going to say, so let me do it in 2 parts. So I'll actually down here, let's do the probability that x is less than 10. And then I'll do the 1 minus. So let's do this one first. And so the probability that x is less than 10 is going to be, so let's go back and let's grab our function. So binomial distribution, less than 10, so 9 out of the 15, and the probability is 0.73, and cumulative true. Now let's do the probability. So this is the one that we're really interested in. So let's do 1 minus this. So the probability that x is greater than 9, so your successes are greater than 9, is 0.80418. And so that's what Excel says. So our rules are 3 decimal places, 0.804. So I wanted to show you how to use and why we would want to use the true function when we're doing the binomial distribution as opposed to the false function. So when you want to cum the values, the probabilities, you want to use true. And when you want just the point probability, you want to use false.